Hello, folks. So you just heard Casey give a case for why sometimes complexity is good and sometimes complexity is bad. And if you want to take away the TLDR of my talk today, what I'm going to tell you today is that n-managed complexity is bad. But I'm going to be giving you today 4 tips for how to manage the complexity in your production systems so that you can make them successful. So I know that not everyone in this room has an operations background. So I'm going to start by saying that, those of us who write code, those of us who facilitate code, right, we try to write code as software developers to solve problems. But your job is not done when you commit the code, right? Like, that's the thing that Gene made clear this morning, right? That you are responsible for actually seeing delivery of value through to the end user. And that means that we have to worry about things that are concerns other than just the writing of the code itself. So for instance, we have to think about things like, that's very strange. Oh. My thing just jumped suddenly. Great. OK. So it means that we have to worry about making our services scale out, that we have to make sure that our services can deliver the new features that we expect. And it means that we are always adding complexity to our systems. And it's a question of how we cope with it. Complexity is inevitable, and we have to figure out how to cope. So we have microservice architectures, right? If you adopt Gene's recommendations and say, you know what, we're going to decouple things as much as possible, well, guess what? That no longer fits in someone's head, right? You can no longer hold the entire shape of your architecture in one person's head. If you have a lot of data, again, right, like, all of that data cannot be processed on one machine. You're going to end up in an environment where you have to have multiple different things communicating. And as we know, the hard problems in computer science are off by 1 errors and concurrency. So we're adding complexity all the time. And we need to figure out how to cope, because we cannot understand or tame it if we don't have the right set of methodologies. And if you cannot understand or tame it, then you are doomed to failure. So I want to reflect for a moment about what uptime means. Because way back in the day, when I was a wee sysadmin, I was yay tall, it used to be that we could measure uptime in servers. If the game server was up, it was 100% up. If the game server was down, all of our users were screaming at us, right? Unfortunately, that's not the world that we live in today. And we can't wait until our users scream at us to say, OK, we're going to take your concern seriously. We have to be a little bit more proactive than that. So we need to think about how do we actually deliver features, improve reliability, and actually manage the day-to-day, right? How do we find time to do all of these things? So I think it's possible. And sometimes you do need to add a little bit more complexity, right? But I think that we need to figure out how to not become overwhelmed by all of this. Because the strategies that got us to here are not going to get us into the future. We have subsisted for too long with a culture of heroism in operations. And that does not work anymore, right? And even a culture of heroism in software development, right? Like, if you are the principal lead architect, right, there's a certain point at which you as a human being stop scaling. So we need to move beyond having individual heroes, and we need to set up to instead move beyond heroism. So this means that we need to have different strategies for how we approach running production systems. And I know this is kind of ironic because I happen to work at a tools vendor, but please do not buy your DevOps. Seriously, do not buy your DevOps. Remember, DevOps is about delivering value. It's about cultural changes, right? So how is a tool going to help you? Well, I've seen people try to buy a DevOps, and this is what I see them doing. Let's go ahead and apply infrastructure as code, because it's one thing to have one stray command be able to take down one box, but what if one stray command could take down your entire AWS environment? Wouldn't that be great? Or how about hooray, this is Australia. It can be colorful with language. So continuous integration and continuous delivery. When they said ship shit faster, I think they failed to recognize that that meant shipping shit faster, right? So we actually aren't testing for quality when we're actually trying to release things faster, right? It turns out that we want to not necessarily micro-optimize the metric of how fast are you shipping, but instead, are we getting the feedback loop done in the correct manner? The other thing I often see people doing is saying, you know what? I've heard about Kubernetes at a conference like YOW. Let's go ahead and adopt Kubernetes. Like, what's Kubernetes? Well, I guess it's hot. I need one, right? Like, it's like, no, hold on a second. What problem are you trying to solve? Does this actually make sense for your use case, or are you adding complexity without a good reason, right? And then, but I think the primary thing that people think of when they think of DevOps is kind of the idea of your teacher ops to code or teacher coders to do ops, and that means handing them a pager. And I argue that handing people pagers in and of itself does not work. Because when you hand a noisy system to someone who is ill-prepared to deal with it, they wind up very quickly turning their pager off or quitting their job or otherwise violently rejecting this idea of, I need to be responsible for my production systems, right? If you get woken up at 3 a.m. every single night, like, you're going to be less productive as an engineer, and you're going to not be able to handle it. So even if you do wind up in a situation where you care about your users, you care about your system, it's 3 a.m., you're stuck debugging, OK, I don't know what any of these dashboards mean. Right? Like, you hit this wall of having 20 different pages of dashboards, each of which has 20 different graphs on it. Which one wiggle at the same time as the other one? Does this handy auto-generated MySQL dashboard help me? Well, I don't know. Is the problem MySQL? I don't know. Right? Like, that is one of the principal challenges that people who tend to adopt this tools-first approach face, is that they add all of this cognitive overhead that inhibits them from actually solving the problem of the actual user. Right? That we have failed to actually optimize for minimizing impact to users and reducing time to fix. And you stare at the dashboards for half an hour or for an hour, and eventually you give up, and you call your tech lead. Right? Everyone winds up bugging the expert, and the expert is not even on call for 1 week out of every 6 weeks. The expert is on call every single day because they get woken up at 4 a.m. every single day after the first person fails to solve it at 3 a.m. So when you get to work in the next day, and you're like, OK, I think I have a fix. Let's try to push it out. And it doesn't work, right? Because even if you're testing each individual component of your system, if you're not testing the whole system end to end, then you're not actually going to be reliably able to push your software out. So when you wind up in a state like this, it's something that we call operational overload, where there's no time to do projects that improve the reliability and scalability and operability of your service. And yet you're expected to try to feed the machine with the human blood, right? To feed human blood into the gears. And even when you do find a spare hour, like, what are you going to do, right? How can you solve this problem in an hour, right? What should I be doing with 1 hour of my time to solve this problem? So people really feel lost in the woods, and like they kind of are stuck there. And a lot of the time, this feels like you dread coming to work, you dread the pager, you dread everything, and you're just struggling to hold on. And every single one of your colleagues feels the same way. Now, I don't want people to feel embarrassed about this, so how many of you have ever been in this situation, either currently or at a past employer, that I feel that lets people off the hook enough that they feel safe raising their hands? How many of you have been in that situation? OK, a lot of us, right? It can be pretty terrifying, right? But what I want to tell you is that there is a way to get out of there. There is a better path. So OK, that raised my anxiety a considerable amount. Like, I have to say that reliving that experience from previous jobs, it raises my blood pressure every time I give this talk. So let's all collectively take a breath together, and then we can figure out how to get ourselves out of this mess. Sound good? OK, that feels a million times better. So what were we missing? Like, what should we have been considering instead, rather than just throwing more humans at the problem? What we forgot was that humans are the people who help run our systems, that our systems are kind of a combination of the technical and social bits, right? That we don't have only technical systems. What we have is socio-technical systems. And that means that we need to focus on the people just as much as we focus on the technology. So no tool is magically going to solve your cultural problem, right? You kind of have to think instead about, what is the overall cultural change I'm trying to achieve? And then once you've started instilling that change, a tool can nudge you, can remind you, can help you, but it cannot kind of reverse something that's baked into your culture that you're unwilling to revisit. So instead, we have to figure out the changes that we're going to make to our people, our culture, and our processes to make our systems more reliable and friendly. And that's what I define the art of production excellence as. Is not just how do we make our systems more reliable, but how do we make them more maintainable? How do we make them more operable by humans? How do we make them friendlier? So you do not get there by accident, right? Like, you have to have a very concrete plan of how you're going to get there, because otherwise you're just going to stumble in random directions and not actually arrive there. And that means that we need to have kind of key metrics, right? We have to track, what milestones should I be looking out for, right? Like, when will I know that I've made some progress? How can I take steps towards improving on those metrics? And I would say that the primary thing that I see people go wrong with is if they don't involve everyone, right? Like, there are a lot of people in this room, right? Many of us identify as engineers, but there's a whole world beyond engineering that really, really matters, right? People who are product owners, people who are finance, people who are support, right? All of these roles matter in order to make sure that everyone feels that the system is operable and meeting the business objectives. And that means that we have to communicate, right? We have to feel that we can pull that safety cord and say, and not feel like someone's going to yell at us, right? We have to feel that we are safe to ask questions about, why do we do things the way that they are done? Can we change it, right? Like, if people don't feel safe asking those questions, you're never going to get anywhere. So how do we get started with production excellence? So today I'm going to tell you about the 4 things that I think are critical towards production excellence. The first thing is that we have to know when our systems are too broken. Because if you don't know when your systems are too broken, you are either alerting all the time on stuff that doesn't matter, or you're not finding out about stuff that really matters. So know when it's too broken. And the second thing is that you have to be able to debug the system. Knowing that something's broken doesn't help you actually debug it, so we have to be able to debug. And the third thing is that we have to collaborate across team boundaries, that we cannot kind of think about debugging as a solo sport. And then finally, we need to close that feedback loop, right? And I realize that in retrospect, given Casey's diatribe about reducing complexity, this may not actually be the best framing, but right, like, if you have something that is repeatedly causing you problems, please stop having that thing repeatedly cause you problems. So why did I say know when our systems are too broken? As I alluded to earlier, our systems are always failing in some way, right? Like, if you have a lawn, and I acknowledge that it is summer in Australia, there are wildfires, like, your entire lawn is probably brown right now. But if you were expecting your lawn to be green, you would be fine if one or two leaves of grass in the lawn were brown, right? That would be OK. The important property is, does the whole lawn look green enough that you can go send your kids and your dog to play on it, right? So in the same way, our systems always are failing in small microscopic ways. So we need to focus on whether they're fit for purpose rather than focusing on each individual's tiny aspect. So that means that we need a measure of what too broken is in our systems. And that's a concept from site reliability engineering called the service level indicator. The service level indicator is common language. It lets us identify, what does the business require, what do our users require, and make sure that we're actually delivering that. In order to measure your service level indicators, you need to understand what your critical users' journeys are. For instance, with an e-commerce site, it might be that someone can load the homepage of the e-commerce site and see items available for purchase, right? If that's not working, that user's not having a good experience. And we have to capture all of the context involved, right? Where is the user? For instance, it may matter a whole deal, right? Like, that, hey, users in Australia are seeing 1,000 milliseconds of latency on every request. Users in the United States are seeing 200 milliseconds of latency. Well, it turns out that identifying those disparities in performance based off of properties of the user or property of the request or which version number, right? Like, those are all important pieces of data that if you're not collecting them, unbeknownst to you, a subset of your users are going to have a really bad time. And I, as a human being, can't sit here and say, what, this request was good, oh, that one was bad, right? Like, I cannot do that. That doesn't scale. So we need a way to teach our computers to understand which events, which user journeys are a satisfactory experience and which ones are a less than satisfactory experience. So one way of figuring out, is this good or bad, is to ask your product manager or user experience researcher, right? Folks like that often have a lot of insight into what the business requirements are. The other way to approach this is to say, what, let's add a little bit of extra latency and see, right? At what point does the website start feeling sluggish? OK, now I know that's a bad experience. Let's dial that back a little bit and say, it's good enough if it's faster than this. So all of this is circling around the idea that we need a threshold, right? Like, we need a concrete definition that our machines can apply. For instance, we might say that that homepage load of your shopping cart is successful if it was served without errors and it took less than 100 milliseconds or 200 milliseconds. But we need to also look at what the denominator is, right? Not just the numerator of how many successes we saw, but what's in your denominator? What's the total pool of eligible events? Is it considered an emergency that your friendly neighborhood botnet is sending you traffic and getting 403s? I don't think that's an emergency, right? So your neighborhood botnet doesn't matter. Neither does your internal health checking, right? The only thing that matters is real user experiences. So you have to tabulate how many successes did you see and how many eligible events did you see. And then you can calculate an availability number that you're aiming for and set a target on it and say, this is what our business requirement is, right? And there's a big difference in terms of the types of business requirements that you have, right? Loading an e-commerce site, it might be OK for it to sporadically fail. Calling emergency services, probably a little bit more important, right? So we kind of have to have different gradations of service level objective targets. But it's not enough to set just a percentage. We also need to figure out how long we look back over. Because it turns out that if I came to you and said, my service was 0% down yesterday, or 0% up yesterday, but it's 100% up today, you would hesitate a little bit before using my service, right? It turns out that people have a fairly long memory. So we have to think about things like, over the past 30 days or 90 days, right, to think about how long are we measuring over? What time scale are we trying to measure over? And it turns out that human memories and our engineering planning cycles actually tend to be roughly the same order of magnitude in the several weeks to several months. So a good service level objective barely keeps people happy, right? That e-commerce site, it might be OK if 1 in 100 or 1 in 1,000 requests fails. The user will just think, OK, I'm going to go ahead and reload the page, and it'll work fine the next time, right? So kind of think about what is your bare minimum user requirement and try to aim for that. Because if you over-index on your availability, what winds up happening is you give up the ability to deliver features and value to your users. Because you are over-delivering on reliability such that you're delivering reliability they don't even notice, right? If you have a mobile phone, right, some of the time it's not going to work because you're in a tunnel or because there's just an outage, right? So why does it matter that your shopping cart service has 1 femtosecond of an availability per year if you're having, minutes or hours of downtime per year from other sources? So what do we use service level objectives for? I argue you can use service level objectives for 2 things. One of which is you can replace that noisy alerting with service level objective alerting, right? Because it turns out that if a disk goes from 89.9% full to 90.001% full, that isn't an emergency, right? A lot of our alerting systems, unfortunately, treat it that way and say, that's an emergency. Wake someone up. It's 90.001% full, right? But what actually matters is delivering quality service to our end users. So let's think about how we can decide whether the service is good enough and make sure that we remedy things before users get too unhappy. So in order to do this, we need to introduce one small concept called the error budget. And it's the inverse of your reliability target. So if I'm targeting 99.9% availability over 30 days, that means that 1 in 1,000 requests are allowed to fail. So then I can say, OK, if I serve 100 million events per month, 0.1% of them are allowed to fail. That means I'm allowed 100,000 failures per month. If I'm draining through 1,000 per minute, I'm going to run out in 100 minutes. If I'm burning through 1,000 per hour, then I'm going to run out in several days. And these have different levels of urgency. So I can wake someone up, and I should wake someone up if I'm going to run out in a matter of hours. But if it's going to take days to run out, it can wait until the next business day. So that lets us efficiently prioritize and prioritize based off of severity of user impact. Fun story. Casey was telling the story about the memory leak of Doom. It turns out that we had a memory leak of Doom at Honeycomb about 2 or 3 weeks ago. And one of the interesting things that happened was that for us, it manifested as a brownout, right? Where for a period of 20 minutes at a time, we would see 2 or 3% of user traffic coming to us failing, right? It was kind of enough that it would impact people's metrics, right? That people would expect to see data that they'd sent to Honeycomb, but it was not getting there for 2 to 3% of the traffic. And this was a case where we realized that, given we target having no more than 1 in 10,000 requests to honeycomb fail, that 2 to 3% brownouts lasting 20 minutes, if those continued all day long, we would be in serious trouble. That meant that we needed to wake people up. That QR code, by the way, is the retrospective if you're interested in reading it. It's kind of fun and interesting, and it talks to kind of the cognitive factors. But unfortunately, this is not a talk specifically about that. So what I'm trying to impress upon you here is that the severity depends upon how bad of an experience your users are having. And in this case, we identified that our users were starting to have a bad experience, and we needed to do something about it. OK, so the second thing that you can use a service level objective for is making data-driven business decisions to say, do I need to speed up? Do I need to slow down? How much of my time should I be spending on reliability work? Gene said this morning, spend 20% of your time on reliability work. I think that number is actually variable. It's up for negotiation. The question is, how well are you doing against your service level objectives? If you're doing well and you have plenty of error budget left, if I'm allowed 100,000 bad requests per month and I've only spent 50,000 of them, you know what? It's OK to run an experiment on 1% of our traffic, right? Maybe try out a new release on them. Maybe see whether they respond better to the color blue or green on the homepage, right? That's a safe experiment to run because we know that the blast radius is contained, and we know how quickly we can roll it back. Conversely, if I've just had a set of bad outages, right, that means that I need to implement some mitigations to bring things under control, right? That maybe we've been a little bit too careless. Maybe we've moved a little bit too fast, and we need to spend more than 20% of our time on reliability work. So having these metrics to give you guidance between your engineering teams, your product teams, and your business teams really helps you crystallize what's the right amount of investment into reliability. And speaking of investment into reliability, right, time you invest into your service level objectives is time, right? So we need to make our service level objectives good enough, right? You don't have to perfectly measure things from your client mobile phones, right? It's good enough to start initially, for instance, measuring from your Amazon load balancer logs, right? That those might be sufficient to tell you more or less whether or not your users are having problems. So measure what you can today, but iterate over time to meet your user needs, right? If you have a mobile app and you introduce a bug in the mobile app, you're never going to see if the requests never make it to your load balancer, right? So at that point, you might want to add more telemetry. But that's not something you have to start with, right? Instead, kind of go based off of what is actually meeting or failing to meet your customers' needs. And yes, sometimes that does mean dialing back your service level objective. If your service level objective says, we expect to have 5 or 6 nines of availability, and you blow that and no customer complains, well, if a tree falls in the forest, did anyone hear it? So you can scale back and deliver the appropriate amount of reliability that your users expect. So if you do this, you're winding up with the correct engineering prioritization, and you're only alerting on what matters. So your teams will sleep better at night. But that's only half of the picture. Because as I said at the beginning, you have to also be able to debug. If you can know when things are too wrong, but you can't actually debug, that's only half of the picture. So our outages are never identical, right? Casey said that that there's no magical one thing you can do to fix your system, right? Otherwise, we'd be better off doing things like buying lottery tickets if you could predict the future, right? Or otherwise, maybe you can predict every single failure mode, and it's because you're having the same failure over and over and over again, in which case you're not doing your job as an engineer. I'm sorry, right? If you're having the same failure and you haven't fixed it, please fix it. So instead, we have to think about those edge cases, right? Our playbooks only get us so far. So we have to be able to debug new kinds of failures that we've never seen before, that we didn't think were going to be there when we wrote the code. We have to be able to debug them and understand them. And it's not enough to debug them in staging. We have to debug them in production. Your customers will not be happy if you say, you know what, great, give me 2 days to fix that critical bug because I need to reproduce it in staging first, right? No. We live in production. We have to be able to test in production. We also cannot have barriers to access to data, right? Imagine if every time you had to debug an incident, you spent 20 minutes asking another team for their data, right? That doesn't work. That slows down your incident response time. So we have to think about how do we democratize access to that data? And how do we make sure that people are empowered both technically and culturally, to ask new questions, right? To interrogate their data to understand, okay, the system is flapping. We're seeing 2% brownouts. What might be going on here, right? To formulate hypotheses of things like, hey, maybe we have a memory leak. Hey, maybe it's one user that's sending us bad traffic, right? Like, to formulate and test these hypotheses is where we spend a lot of our time doing incident resolution. So that means that we have to be able to dive into that data in order to answer the questions, in order to resolve our incidents. All of this is to say that our services have to be observable. The textbook definition of observability says that observability is the ability to diagnose the internal state of a system based off of its externally visible outputs, right? That means you're not allowed to push new code, right? You're not allowed to reach into the system itself and SSH into it, right? Instead, it's what telemetry are you getting out of your system, and can you understand on the basis of that telemetry what's going on inside of your system? So this requires us, in a modern world, to be able to understand each user journey and all of its context, right? And to understand if we're having a set of bad journeys, what's going on with them? Can we explain the variance between the good and bad outcomes? Maybe it's users in Australia are having higher latency. Maybe it's one specific customer that's seeing higher error rates. Maybe it's every request that flowed through microservice A version Y and microservice B version Z, right? Those are potential hypotheses that we need to be able to use to explain what's going on inside of our systems. And that means that we have to be able to see which dimensions are relevant. We have to be able to see things like version numbers, user IDs, right? These are things that are useful for us, both as engineers and as support teams, to understand what's going on. And even better yet, why do we have to be looking at this at 3 a.m.? Why can't we deploy mitigations like rolling back releases or draining regions in order to mitigate impact to users and then look at it during business hours, right? We don't necessarily have to live in a world where every incident has to be happening right now for us to get visibility into it. But I think that people often over-focus on break fix in their observability. Break fix is one piece of what observability can do for you, but there are more pieces than that. We also have to think about things like, as Gene was saying this morning, how do we improve that feedback loop so that you as a developer have confidence in your code as you're writing it on your laptop? Why can't we use the same tools to debug on our laptops as in production? Why can't we have visibility into why our builds and our deploys are taking so long? Why can't we have visibility into the holy grail of user value, right? Why can't we see which users are using which features and whether or not they're successful earlier? And finally, we need to be able to understand what control knobs do I have on complexity and technical debt? Where should I focus my effort? Those are questions that observability empowers us to answer. The other important thing that I'll highlight is that it's not just the data. Like, collecting the data is important, but you need to be able to access the data. You need to be able to generate the data. So we have to think about ergonomic instrumentation paths, efficient data storage, and the ability to issue queries to understand and answer our questions. So hopefully I've persuaded you that you need SLOs to understand when your systems are too broken, and you need observability in order to be able to debug when things are too broken. But there's a missing component. We need to also be able to collaborate. We need to have shared views between different teams about what's going on inside of their services. Because no one person and no one team can hold up the entirety of your stack. We live in a world where all that complexity comes from layers deep of services where people have no idea that a shoe store going out of business is going to cause an entire economy to collapse, right? So you can't expect some guru to understand that that's going to happen and prevent it, right? So instead, we have to be able to communicate across those boundaries, both in terms of being able to work together with other engineers on your team, as well as work together with people that are in entirely different organizations, like the support organization, the sales organization, right? We all have to be able to collaboratively debug, or else we're going to wind up pointing fingers and say, that's not my problem. It's your problem. We also have to work together, right? We have to practice before there are serious outages, right? As Casey was saying, there are so many near misses that we can learn so much from, and we can also artificially test and verify that are we able to successfully collaborate together. This means that we need to build up those interpersonal skills, that we need to value and reward them just as much as we reward technical skills. We also have to think about how do we build up those trust relationships between teams when there's not an active outage going on. And finally, it's a team sport, right? Like, no one person can be on call 24/7. There are religious reasons, there are family situations, and there are job role situations where being on call for 168 hours straight just does not make sense. Collectively, we need to have the right mixture of skills on our teams. Collectively, we need to be able to do on-call for our services. That doesn't mean it has to all fall on one person. We also learn from documenting, right? To make sure that we can up-level other people who come onto our teams, to make sure that they can gain a similar understanding of the services that we run as other people who have been around for longer. That doesn't necessarily mean over-documenting, but what it does mean is that people feel free to ask questions, right? Instead of me going to Chris when she asked me a question and saying, I can't believe you didn't know that, Chris, right? Wouldn't it be better if I said, thank you for asking me that question, Chris. I'm sorry that the documentation wasn't clear. Let's write down how the system behaves, right? That's so much better. And we have to use the same platforms and tools so that we can collaborate and have the same view of the data, so that we can all feel comfortable having ownership over our instrumentation and understanding of how the data gets to where it is and how we can query it. We have to reward curiosity and teamwork and adopt a blameless post-mortem culture. That was a mouthful. So that means that we have to do things like, not yelling at people and saying, you know what, it was your outage that caused that, or it was your change that caused that problem, right? Because that makes a person feel not safe to raise their hand and say, hey, I think that my change that I pushed 20 minutes ago might have caused that outage, right? True story. With the very large Google Cloud outage that happened in June of 2018, that change that a developer made that wound up causing a cascading failure inside of Google Cloud, it turns out that the outage was resolved a lot faster because that developer put their hand up and said, I think it was me, right? We celebrated that developer because that really did make a huge difference as opposed to people hunting around with the person feeling really shy and defensive, right? But I think there's an additional element of making sure that we're collaborating not just with our current colleagues, but also with our future selves, right? You today are not the same person as you 12 months from now who has long forgotten about what you're working on today, right? So we have to write down what we're learning. We have to write down the state that's in our heads, but write down the right amount of context. As Casey said, there's no perfect runbook, right? Instead, we just have to focus on what does someone need to know at a glance, what mitigations are the immediate turn-it-off mitigations. And everything else, if you improve your ability to respond and iterate, you're going to have much better success. So it is true that root causes are a fallacy, but if you know that your MySQL server is going to inevitably go down, it probably makes sense to plan and figure out what are you going to do when that MySQL server goes down. So our outages are never exactly identical, but you can see common patterns. And that means that we can plan for those common patterns. So I swear I did not deliberately plan this, but yes, this looks an awful lot like the Sydney Harbor Bridge. So let's suppose that the Sydney Harbor Bridge has some holes in the roadbed, and cars are falling through. And it also, this is along the rim of fire. There may be an earthquake in 30 or 50 years. So maybe it needs an earthquake retrofit. Oh, and it needs a fresh coat of paint. Which one of those do I address first? Well, we need to think about the impact to people, right? How do we maximize the return on investment? So we need to think about how often do we expect a failure to happen, and how bad is it? And often, we do not have control over the frequency, right? I know that earthquake is coming. I don't know when. I can't control it, but I know it's coming, right? On the converse side, though, we can have impact over the severity, right? We can say, you know what? If that MySQL server fails, instead of it taking out 100% of my users, maybe it can only take out 1% of my users if I shard my MySQL server. Or maybe instead of it taking out all of my production environment for 3 hours while I rebuild the database, what if the MySQL server failing just meant that the redundant MySQL cluster took over within 2 minutes? So thinking about percentage of users impacted, detection time, and how long it takes you to recover, that's going to serve you a lot better than trying to prevent incidents from happening. And we can multiply these things together and say, you know what? If I am allowed 100,000 bad requests per month, how many bad requests do I expect to happen from MySQL inevitably failing? And I can decide, is it worth fixing MySQL or is it worth fixing my web server, right? You can prioritize based off of your error budget and the service level objective. And you can decide, you know what? The car's falling through the roadbed, that's the most important thing to fix, right? That's the highest impact. And that means that we need to address it or else we're not achieving our goals for this bridge. And that enables you to go back to your business stakeholders and say, you know what? I would dearly love to deliver you that new feature, but right now, we are not reliable enough, and no one's going to see that new feature because they're fed up with our service and are leaving because we are not achieving our service level objectives. And that enables you to say, OK, we're going to prioritize completing these things that are going to enable us to stay within our error budget. Now, of course, you cannot predict every failure, right? So the important thing is that you need to leave room in your error budget for the unknown unknowns, as well as for the things that you know are going to eventually break. But by doing this planning, you can prioritize working on what matters and not working on vanity projects that don't actually improve the reliability of your service or the functionality of your service. Please do not waste your time polishing the chrome on your car if your car has a serious mechanical defect, right? We have to prioritize functionality first. But I think the things I'm going to leave you with are that people often overlook systemic risks, right? If you have, MySQL failures, web server failures, load balancer failures, right? You can kind of categorize and bucket and address each of those individual risks. But it turns out that lack of observability is a systemic risk. If you lack the ability to tell when you're having an outage for 20 minutes or 30 minutes or 2 hours until someone calls on the phone and says, hey, it's broken, that's a huge impact to users. That's a huge risk. Or if you spend 3 hours or 5 hours or 12 hours debugging your outages because you lack the ability to introspect your system, and that happens for every outage that you have, that's a systemic risk, and it prevents you from achieving your business objectives. So really, investing in observability is kind of like clearing the snow off your car before you go driving, right? It's kind of really important to be able to see where in the heck you're going. The second thing that I want to highlight is that it's important that people feel like they're able to collaborate, right? If I wind up in a situation where I'm that engineer and the last time that I said, hey, it was my fault, I got yelled at, right? I'm not going to raise my hand the next time. Or if I'm someone in support and I call the engineers and they say every time, oh, that user's stupid, don't bug me with that again, right? You're not going to find out early about that huge outage. So make sure that your people are collaborating or else it's going to damage your time to resolve every single incident. So you don't have to be a hero to run a successful service. What you do need to do is, yes, buy the right tools that facilitate your culture, but also really invest in that culture. Invest in production excellence in order to make sure that you're able to sustainably run a reliable service. So measure when things are too broken, be able to debug them when they are, collaborate with other teams, and close that feedback loop and fix common triggers of outages, and you'll have a much better time. Thank you very much.